Let us understand how we should take care of loading data in batches. We'll perform load using multiple approaches to understand which one is better. Approach 1 will be inserting and committing each record. Whenever there is a commit in database, there is considerable amount of overhead. This should be avoided. You will understand why it should be avoided after going through this topic. Another approach will be insert one record at a time but commit at the end. Then insert all records at once and commit at the end. Then insert records in chunks or batches and commit per chunk or batch. We should follow the fourth approach while dealing with huge amounts of data. It will facilitate us to restartability or recoverability, but it compromises the performance up to an extent. But it is okay. We should prefer the fourth approach of all these four approaches. That being said, let's run this to create SMS underscore connection as well as retail underscore connection database connection objects. In this case, we'll be using retail underscore connection object. We already created the tables for orders and order items. We'll be using the same tables here. I am going to define a function called as getCursor to return a cursor. This will take care of reading both orders as well as order items into the data frames. I have covered this already. It have a function called as get underscore df, and we have invoked that for both orders and order items. Once it is run, we should be able to validate by running these two to ensure that we have two data frames by names orders and order items with records in them. You can see here the reason why we are seeing output is because we have this percentage sh head uncommented. That's why we got that output. Let me comment these things out and let me run this once again. Now the data frames orders and order items are created. We can validate by running these two. You can see first three records from both orders as well as order items data frames. Now when it comes to query, this is how it will look like. It is nothing but a query string where we have insert into the table name and the column names in circular brackets and then placeholders for all the four columns. Let's define this query string. Then we can actually use this function to insert one record at a time and commit. You can see here it is taking connection object, cursor object, query string and data. Data should be list of lists or list of tuples so that we can iterate through that list and we should be able to pass it to execute to insert one record at a time. You should be able to define this function. There is nothing fancy here. Using the data, which is nothing but list of lists, we are iterating and we are trying to insert the rec in each iteration using cursor.execute by using this query string and one record at a time, and we are trying to commit for each and every execute statement here. Both cursor.execute and connection.commit are under this for loop. Now the function is defined. We should be able to define the cursor object by saying cursor equal to get cursor of retail connection. Now let's invoke load underscore orders using this percentage time. It will try to compute how much time it took to actually invoke this load underscore orders. This load underscore orders takes four arguments: retail connection object, the cursor, the query, which is nothing but this one, and then orders.values.toList of 10,000, which means we are trying to insert 10,000 orders out of 68,883 using this function call. Now I can run this. It will take approximately 7 to 8 seconds just to insert 10,000 records because of the commit. It is trying to commit for each and every record, and you can see that it took almost 7 seconds just to insert 10,000 records, which is pretty slow. Now let's truncate this table and let's commit this. Now let's try to insert one row at a time but committing at the end. So we'll commit at the end. Even though it is much faster than previous approach, it is transferring one record at a time between Python engine and database engine. As long as the Python engine and database engine are co-located, the performance will be good. But if your Python engine is separated from your database engine, then it will actually take quite a bit of overhead just to transfer the data between Python engine and the database engine. We can further tune by leveraging batch insert even when the database engine and Python or application engine are separated geographically. For now, let's run this. In this case, the difference is I moved out connection commit from the for loop. We are committing only at the end. Now, if I run this, it will create the function load underscore orders for us. Let's create the cursor object. In this case, I'm inserting all orders and committing at the end. You can see here, I haven't specified of 10,000 here, which means we are trying to insert all 68,883 records into the table. Now let's see how long it takes. Earlier for 10,000 records, it took 7.49 seconds. Now for 68,883 records, it took 5 seconds, which means it is at least 20 times faster. Okay, because to load 68,883 or 70,000 records, it will take 7 times of this, which is approximately 50 seconds. we got it done in 5 seconds, which means this is at least 10 times faster than this approach. It is due to the fact of committing every record using this approach, taking a lot of overhead. Now, if we commit at the end, the performance will be a lot better. Now, if you want to insert all the records using execute many and commit at once, this is how it will look like. We are not iterating anymore here. If you look at the logic, it takes 4 arguments: connection, cursor, query, and data. As long as data is list of lists, we can use execute many, pass the query along with the data to it, and it will take care of inserting all records in one shot using execute many, and it will commit after all the records are inserted. Let's define this function, create the cursor, and then insert all the records by invoking this function. This time also it will take approximately 5 seconds. You might not see significant difference in performance as our database is running in the same server from where the code is running to insert the data. If they are geographically separated, then this will be a bit faster compared to the previous approach. Now let's truncate this table and now define this function called as load_orders, where it actually insert 10,000 records in each execute many and commit for each 10,000 records. So in this case, we are iterating through all the records by saying 0, len of data, batch size. In this case, batch size is 10,000. So it will iterate 10,000 records at a time. Let me demonstrate what I'm trying to achieve here. So we have orders. Okay, so orders is nothing but data frame. We can say values.toList. You can check the len. It is nothing but 68,883. Now, if I say a range of 0, len of whatever this is, then 10,000, and let's invoke list on top of it so that we can see all the values. You can see that it is returning 0, 10,000, 20,000, 30,000, 40,000, 50,000, 60,000. Okay, so we are trying to process data from 0 to 10,000 in first iteration, 10,000 to 20,000 in second iteration, 20,000 to 30,000 excluding 30,000 in the third iteration, so and so forth. The upper bound is excluded in each iteration. So in the first iteration, it will be 0 to 9,999. In second iteration, it will be 10,000 to 19,999, so and so forth. As part of the last iteration, it will be from 60,000 to whatever the batch size is, which is nothing but 68,883. So it will try to process all the data in 10,000 batch at a time. So each batch will contain 10,000 records. You can see the logic here. This will take care of generating these numbers 0, 10,000, 20,000, 30,000, 40,000, 50,000, 60,000, etc. In each iteration, we are saying query and then data of I. So in the first iteration, I will be 0. I plus batch size will be 10,000. So it will populate first 10,000 records. In the second iteration, I will be 10,000. And I plus batch size will be 20,000. So it will process data within this range. In the third iteration, it will process data within this range. In the fourth iteration, it will process data within this range. In the fifth iteration, this will be the range. In the sixth iteration, this will be the range. In the seventh iteration, from here to 68,883. And hence all the records will be inserted into the table, committing every 10,000 records. If you plan it properly using this approach, even if it fails for one or a few batches, we should be able to recover only those batches. We don't need to reprocess everything. Now let's create this cursor object and invoke load orders with retail connection, cursor, query, and orders in the form of a list. Here we are trying to insert 10,000 records at a time and committing every 10,000 records. This is a better approach compared to others because we can keep track of what is committed successfully and what is not committed if we design it properly, and we should be able to restart and recover only those batches which have failed. So as the data volumes grow, we typically follow this approach over other approaches. Now let's load the SQL magic, create the database_URL environment variable, and let's validate the number of orders in the table. It is nothing but 68,883, which validates our logic. Even though we have loaded in batches, we got all the data into the table without any issues. So this is how you should be planning your bulk loads, by ensuring that it is inserted in chunks or batches and committed per chunk or batch. This is the better approach compared to others while dealing with huge amounts of data. Keep that in mind and make sure you are comfortable with respect to batch loading into the data, especially from the inserts perspective, so that you can think about potential issues and develop your batch data pipelines more efficiently.